Hi everybody, we're in section 2.2 of trigonometry now, and we are going to be learning this time about reference angles, special angles as reference angles, and finding angle measures using special angles. So this one's all about the reference angles. Let's get started. Okay, first of all, a reference angle is an angle that's a positive acute angle that's between the terminal side of our original angle and the x-axis. For example, here is an angle in quadrant 2. Okay, theta is the original angle, and theta prime is this smaller angle that's between the terminal side and the horizontal. That is our reference angle. If your angle is in quadrant 3, the reference angle is here between the terminal side and the horizontal axis, right here. It's always acute, so it could not be this angle here. That's not acute. It's always going to be less than 90 degrees between the terminal side and the horizontal axis. If your angle is in quadrant 4, like this theta is in quadrant 4, then your reference angle would be here between the terminal side and the horizontal axis. So it's always easy to locate the reference angle. Now, one mistake people make a lot of times is they try to find the smallest angle they can, and they will frequently go to the y-axis instead of the x-axis, but your reference angle always has to go toward the x-axis. So let's find the reference angle for 218. Now here they've already drawn for us 218 degrees in standard position, and the reference angle is this little bit here. Okay, now if the negative x-axis represents 180 degrees, then the difference between 218 and 180 is going to be our reference angle, which we call for this part of the section theta prime. Okay, that's 180 right there, and then here's theta prime. So if we just subtract, the little reference angle is 38 degrees right in there. In part B of example 1, it says find the reference angle for 1387. Now, it's impossible to tell where to draw 1387 unless you first figure out what angle is coterminal with it that's less than 360. So I'm just going to subtract 360 until I get down to something that is less than 360 degrees. Now that I see that it's coterminal with 307, I know exactly where to draw 307. It needs to go in the fourth quadrant. Okay, now the reference angle is between the horizontal axis and the terminal side. So the reference angle, what we can do to find it is we can take 360 and subtract 307 degrees, and that will leave you this little bit here. Okay, so it looks like the reference angle is 53 degrees. Now here's a little chart that shows you where the reference angle is for every type of angle in every quadrant. We've got in quadrant 1, your angle would be here, and theta prime, or the reference angle, is also the same. So in quadrant 1, the angle is the same as the reference angle. In quadrant 2, the angle is here, and the reference angle is here. So it looks like if you start with 180 and you take off the original angle, what's left over will be the reference angle. Now for quadrant 3, the angle goes from here to here, and the reference angle is this bit here. You can see that the reference angle overlaps part of the original angle. So if you take the original angle and subtract 180, what's left over will be the reference angle. Okay, for quadrant 4, what you want to do is start with 360 and subtract theta, and what's left over will be theta prime. Okay, I hope that you really don't have to memorize these. I really hope that you can just tell by looking how to find the reference angle, because it shouldn't be something that's like a big, burdensome, tedious task for us. Here's a little chart that I drew to help you understand the purpose of reference angles. Each angle in this chart has the same reference angle. So here's theta. Its reference angle is theta prime. Here is a theta that's drawn in quadrant 2, but its reference angle is the same. That's why you see we have this terminal side contains 3, 4, and this terminal side contains negative 3, 4. That means that the little angle here is the same as the little angle here. And when we go to quadrant 3, we've got negative 3, negative 4. That means that the little angle here, this reference angle, is the same as what we had in quadrant 1, the same as what we had in quadrant 2. And when we go to quadrant 4, the terminal side contains 3, negative 4. So that means this little angle here is the same as this little reference angle, which is the same as the other 2 little reference angles. So the important thing here is that every coordinate system contains a theta that has the same reference angle as all the others. Now, let's go ahead and find sine, cosine, and tangent for each of these angles. So for the first one, we're in quadrant 1. All the functions are positive in quadrant 1. All we have to do is label our horizontal and vertical sides, 3 and 4, and that means the hypotenuse is 5. And then sine is going to be vertical over hypotenuse, cosine is horizontal over hypotenuse, tangent is vertical over horizontal. Everything's positive in quadrant 1. Let's go to quadrant 2. And remember that this is the same reference angle as the last one. So we'll drop our perpendicular line there. We'll label the sides of our triangle. They're all the same. This time let's go ahead and label ASTC just to help us remember what's positive where. Okay, sine is going to be 4 over 5, and sine is positive in the second quadrant. Cosine is going to be 3 over 5, and it is negative in the second quadrant. Tangent is going to be 4 over 3, and it is negative in the second quadrant. Let's do quadrant 3. Here, this little reference angle is the same as that one. And so when we label our triangle, all the sides are the same as the last 2. And we'll just have to remember ASTC. We'll know that tangent is positive in the third quadrant. So sine is going to be 4 over 5. But it's negative, see, because sine is negative in the third quadrant. Cosine is going to be 3 over 5, but it's negative because cosine is negative in the third quadrant. And tangent is going to be positive 4 over 3. Now in the fourth quadrant, sine will be vertical over horizontal. So sine will be negative 4 over 5. Cosine is positive in the fourth quadrant, so it's going to be positive 3 over 5. Tangent is negative in the fourth quadrant, so it's going to be negative 4 over 3. So I really want you to see that for all of these angles, the sines are all 4/5, but sometimes they're positive and sometimes they're negative depending on their quadrant because they all have the same reference angle. That's what reference angles do for us. And then cosines, all the same. They're all 3/5, but some are positive and some are negative because they all have the same reference angle. And the same thing for the tangent. So the beauty of a reference angle is that it lets us match up an angle in quadrant 2, quadrant 3, quadrant 4 with an angle in quadrant 1. So we can always know the trig functions no matter what quadrant the angle is in. So, for example, here, let's find the 6 trig functions of 210. Now, I want to draw 210. Okay, 210 is in the third quadrant, and the reference angle would be right here. So the reference angle would be 30. And therefore, the sine, cosine, and tangent of 210 are the same as the sine, cosine, and tangent of 30. except we have to adjust the signs because we're in quadrant 3. So sine of 210 is equal to sine of 30, which is 1/2, except we're in quadrant 3 and sine should be negative. Cosine of 210 is going to be equal to cosine of 30, so square root of 3 over 2, except we're in quadrant 3 where cosine should be negative. Tangent of 210 is going to be equal to tangent of 30, except, well, we're in quadrant 3 where tangent is positive, so that one's positive, that's okay. Now the other three functions we know are reciprocals of the first three. So cosecant is going to be negative 2. Secant is going to be negative 2 over square root of 3, but if we rationalize that, we'll get negative 2 square root of 3 over 3. Cotangent is going to be, well, I don't want to rationalize this. I want to remember that this has already been rationalized. Before we rationalized it, it was 1 over square root of 3. So when we turn that over to do the reciprocal, we get square root of 3. Here's a slide that just has the steps of how to do what we just did in the last example. It says if your angle is larger than 360 or less than 0, you have to start by finding a coterminal angle that's between 0 and 360. That will help you know what quadrant your angle is in. Then you can find a reference angle between the terminal side and the horizontal. After you know the reference angle, you can use that to know the trig function values for the original angle, and then you use ASTC to determine the sines. Alright, so let's do that for cosine of negative 240. Now it's negative, so it needs to go clockwise. If we go clockwise 240 degrees, we go past 180 by 60 degrees. That means our little reference angle here is 60 degrees. Alright, now the cosine of 60 is going to be equal to the cosine of negative 240. Cosine of 60 is 1/2, but we're in the second quadrant where cosine should be negative. Let's do 675. Now 675, when you first start out, you have no idea where to draw it. So if you subtract 360, you find out that the coterminal angle is 315. I know 315 is in the fourth quadrant, and 315 is 45 degrees away from 360. So the reference angle is 45. And let's see, so we're really kind of looking for tangent of 315. Tangent of 675 is equal to tangent of 315, which is equal to the tangent of 45 except for the sine. So tangent of 45 is 1, but we're in the fourth quadrant here where tangent should be negative 1. Alright, let's find all 6 trig functions for these two angles, just for practice. Okay, 120 degrees. So we've got our coordinate system with 120 degrees drawn on it, and we can see that the reference angle would be 60. So the sine of 120 is the same number as the sine of 60, which is square root of 3 over 2. And we're in the second quadrant where sine should be positive. Cosine of 120 is the same number as cosine of 60, but we're in the second quadrant where cosine should be negative. Tangent of 120 is the same number as tangent of 60, so that's square root of 3, but we're in the second quadrant where tangent should be negative. Cosecant of 120 will be the reciprocal of square root of 3 over 2. So if you rationalize, you get 2 square root of 3 over 3. Secant of 120 will be the reciprocal of cosine, so that's going to be negative 2. Tangent or cotangent of 120 will be the reciprocal of tangent, so that's going to be negative square root of 3 over 3. Okay, now 315, I know we just did one of the functions for it just a minute ago. If you draw it, it's in the fourth quadrant, reference angle 45. So sine of 315 is the same as sine of 45, except the sign is different. The SIGN sign is negative. Square root of 2 over 2. Cosine of 315, we're in the fourth quadrant where cosine should be positive, so it's positive square root of 2 over 2. Tangent of 315, we're in the fourth quadrant where tangent is negative, but the tangent of 45 is 1, so this is negative 1. For cosecant, we take the reciprocal of this value, but remember this has been rationalized, so if you remember its unrationalized form was 1 over square root of 2, so this reciprocal is going to be negative square root of 2. Secant is going to be positive square root of 2 because you do the reciprocal of this value. And cotangent is going to be negative 1 because you do the reciprocal of tangent. Now you need to get into Quizlet, get in my math lab, find the Quizlet link for the stuff from section 2.2 and use that to drill yourself because you got all these special angles and all the different quadrants and you really need to be fast about doing it. You can't sit and think and wonder. You have to drill yourself until you're pretty fast at it. So I would encourage you to do that. Let's go ahead and let's try an expression that has some squared values in it. So this says cosine of 120 plus 2 sine squared of 60 minus tangent squared of 30. So first of all, I want to draw 120 because that's the only thing that's not in the first quadrant here. So 120 has a reference angle of 60. Now the cosine of 120 will be the same as the cosine of 60, except for its sign. Its cosine of 120 is negative 1 over 2 because it's in the second quadrant. Alright, now, so cosine of 120 is negative 1/2. Now this square means that we find the sine of 60 and then we square it. So this is going to be 2 times the sine of 60 squared. That's what that says. 2 times the sine of 60 squared. And then this says minus the tangent of 30 squared. So tangent of 30 is square root of 3 over 3, and we're going to square it. Okay, let's use order of operations just like you did back in beginning algebra. We will square this value. Square root of 3 over 2 squared becomes 3 over 4. Square root of 3 over 3 squared becomes 3 over 9, which of course can be reduced. Okay, now we will go ahead and multiply. We'll reduce 2 over 4 reduces to 1 over 2, so that becomes 3 over 2. 3 over 9 reduces to 1/3. Then you've got negative 1/2 plus 3/2 minus 1/3. Okay, common denominator here would be 6, so 1/2 becomes 3 over 6. 3/2 becomes 9 over 6, and 1/3 becomes 2 over 6. So negative 3 plus 9 minus 2 is 4 over 6, which reduces to 2/3. Of course, this can be done on the calculator. You can pretty much type it in almost like you see it here, but you need to know how to put this in and square it. So, on the calculator, remember to close the parentheses after you finish entering your angle before you square. Square after you close the parentheses. So on the calculator screen it would look like this. Now we would never ever write it this way on paper because you can see that it's a little confusing. It looks like the angle should be squared, but that's not the case. It's the function value that gets squared, not the angle. So the calculator understands this, but that's not the way we write it ourselves. And it comes out 0.666666667. That 7 is because it had to round off because it got to its last display digit. And if you convert this to a fraction, it'll tell you 2/3. Now the f to d function is the second function of the probability button. And so if you have this on the screen and you do second prob equals, then you'll get 2/3. It will convert a fraction to a decimal. Okay, let's find the cosine of 780. because that angle is so large, the first thing we'll have to do is find a coterminal angle, and the coterminal angle is 60 degrees. Okay, that means that the reference angle is also 60 degrees, and that means that the cosine of 780 is the same as the cosine of 60, which is 1/2. Now let's do the cotangent of negative 405. First I have to start by adding 360 until I get an angle that's between 0 and 360. Once I get that, I know where my angle is, and so cotangent of negative 405 will be the same as cotangent of 315. And the reference angle here is 45. And we know that the cotangent of negative 405 is the same as the cotangent of 315. So it's the same as the cotangent of 45, but except it's in quadrant 4, so it's going to be negative. So the tangent of 45 is 1, that means the cotangent is 1, but in quadrant 4 it would be negative, so negative 1. Alright, now let's work backwards a little bit. This says find all the values of theta if theta is between 0 and 360, and the cosine of theta is negative square root of 2 over 2. Okay, when I do this, I start by drawing a coordinate system, and then I label the quadrants where I could find a negative cosine. I could find a negative cosine in quadrant 2, and I could find a negative cosine in quadrant 3. Okay, now the square root of 2 over 2 is another clue. What reference angle matches square root of 2 over 2 as a cosine value? Well, that would have to be 45. So we know the reference angle is 45 from memory. Okay, that lets us label here and here. Okay, now 180 minus 45 gives us our first angle. So this one is 135. And 180 plus 45 gives us our second angle. So that one would be 225. Let's do a few more that are similar to that. Find all the angles of values of theta if theta is between 0 and 360 and has the given function value. So for this first one, if the sine is negative square root of 3 over 2, we know that we can nail down it has to be quadrant 3 or quadrant 4. Okay? And then we use the square root of 3 over 2 to determine the reference angle. Remember, reference angle goes to the horizontal. So a sine of the square root of 3 over 2 would mean a 60-degree reference angle. Okay, so I've labeled those here. Now, for the third quadrant, we'll do 180 plus 60, which would be 240. And for the fourth quadrant, we'll do 360 minus 60, which would be 300. Okay, let's look at this next one. If the cosecant of an angle is negative square root of 2, then that means the sine of that angle is negative 1 over square root of 2. And, of course, that's equal to square root of 2, negative square root of 2 over 2. Alright, now, we're going to draw our two coordinate systems because with a negative sign value, we could have an answer in quadrant 3 or quadrant 4. Then the square root of 2 over 2 tells us the reference angle is 45 degrees. And then we can say, alright, 180 plus 45 is our first answer, and 360 minus 45 is our second answer. And then let's do number 90. Cotangent of theta equals negative 1. Well, if cotangent is negative 1, then the reciprocal of that means tangent is also negative 1. And so what two quadrants could I have negative tangent? I could have a negative tangent in quadrant 2, and I could have a negative tangent in quadrant 4. So the reference angle here, what angle has a tangent value of 1 that we memorized? It would have to be 45. The reference angle is 45. So the first answer here is 180 minus 45 is 135. And the second one, 360 minus 45, gives us 315.